section 1.4. F of x equal 1 over x minus 4, g of x equal 1 over x minus 1. We want to find the function and its domain, f plus g. So we just add the two functions, 1 over x minus 4 plus 1 over x minus 1. And you can't have denominator 0, so that means x cannot be 1 and x cannot be 4. F minus g of x, the same thing, except instead of plus in between, we'll have a minus sign in between. And again, x cannot be 1, x cannot be 4. Here we have no operation symbol. It's assumed to be multiplication. We want to multiply the numerators, multiply the denominators. 1 times 1 is 1. And we can just show the multiplication here. Again, x cannot be 1, x cannot be 4. A division, divide by fraction. You want to flip the fraction, change it to multiplication, and multiply straight across. 1 times x minus 1 is x minus 1. X minus 4 times 1 is x minus 4. Again, x cannot be 1, x cannot be 4. In the final answer, it looks like maybe x can be 1, but if x is 1, you can't get past this first step here, where we're dividing by 1 over x minus 1. You can't have x in the denominator. Okay, so f composed with g. This is a sort of a different type of operation here, and it's very important in calculus. This is called composition of functions, and it's represented by a little circle in between f composed with g, and it also can be written as with a double set of parentheses, f of g of x. And in the formula for f of x, wherever you see an x, you want to put a g of x. So the formula for f of x is 1 over x minus 4. So f of g of x will be 1 over g of x minus 4. And then the formula for g of x is 1 over x minus 1. So we replace g of x by 1 over x minus 1. And then we have a fraction within a fraction. So we want to multiply each term by the denominator of that fraction. So it'll be multiply each term of the by x minus 1. So in the top we'll have 1 times x minus 1, which is x minus 1. This part here, the bottom left, the x minus 1s will cancel and we'll just have 1. And then we can distribute the 4 here. We have negative 4 times x minus 1. If you distribute the 4, that gives us negative 4x plus 4. And if we combine like terms, we'll have 1 plus 4 is 5. So we have x minus 1 over negative 4x plus 5. And x cannot be 1, because if x is 1, you can't get past this step here. And also x cannot be 5/4, because in the final answer, if x is 5/4, I will make the denominator of the final answer equal to 0. So x domain is anything except for 1 and 5/4. We can also compose a function with itself. If we compose f with itself, we have f of x. So in the formula for f of x, instead of 1 over x minus 4, we'll have 1 over f of x minus 4. And then replace f of x by its formula, which is 1 over x minus 4. And then do the operation. So we want to we have a fraction within a fraction. So we want to multiply by the denominator of the inside fraction. So multiply the top by each term by x minus 4. So 1 times x minus 4 is x minus 4. The bottom left, the x minus 4's will cancel, we'll just have 1. And in the bottom right, we want to distribute the negative 4, and that'll give us negative 4x plus 16. And then if we combine like terms, 1 plus 16 is 17, and so the answer is x minus 4 over negative 4x plus 17. X cannot be 4, otherwise we can't get past this step here. And also, x cannot be 17 over 4, because that will make the denominator in the final answer equal to 0. Okay, well here we have discrete functions. We have f has just these 3 points here, these 3 ordered pairs, 1 comma 1, 2 comma 3, 3 comma 2. G is 1 comma 3, 2 comma 1, 3 comma 2. And if we want to find f plus g, well, when the input is 1, f is 1 and g is 3. So the f plus g will be 1 plus 3, which is 4, if the input is 1. If the input is 2, f is 3 and g is 1, so f plus g will be 3 plus 1, which is 4. If the input is 3, f is 2, g is 2, the output will be 2 plus 2, which is 4. So the combined function f plus g will be 1 comma 4, 2 comma 4, and 3 comma 4. F minus g, and the domain is 1, 2, and 3. The domain would be the first coordinates, 1, 2, and 3. If x is 1, f minus g will be 1 minus 3. F is 1, g is 3, so it's 1 minus 3, which is negative 2. If the input is 2, f minus g will be 3 minus 1, which is 2. That'll give us 2, 2. And if the input is 3, f minus g will be 2 minus 2, which is 0. So the new function is 1 comma negative 2, 2 comma 2, and 3 comma 0. And again, the domain is the set of first coordinates, which is 1, 2, and 3. F times g, if input is 1, output will be 1 times 3, which is 3. F is 1 and g is 3. If input is 2, f is 3 and g is 1, so it's 3 times 1 is 3. If input is 3, f is 2, g is 2, 2 times 2 is 4. So the new function is 1 comma 3, 2 comma 3, and 3 comma 4. F divided by g, if the input is 1, f is 1, g is 1, f divided by g is 1 divided by 3, which is 1/3. If the input is 2, we'll have 3 over 1, which is 3. If the input is 3, we'll have 2 over 2, which is 1. So the new function, 1 comma 1/3, 2 comma 3, 3 comma 1, and the domain 1, 2, and 3. Composition, f composed with g. So we want to do the second function first. The outputs for g become the inputs for f. So for the inputs 1, 2, and 3, applying g to those gives outputs of 3, 1, and 2. And then if we apply f to those, take those as inputs for the function f, 3 goes to 2, 1 goes to 1, 2 goes to 3. So the new function take the original inputs and the final outputs, put those with the final outputs. So we have 1 comma 2, 2 comma 1, and 3 comma 3. And that's our new function. Domain would be the original inputs, which is 1, 2, and 3. Okay, so here as functions, I have neither a list of points nor a formula. I just have a graph. But we can still use the graph to combine these two functions. So f plus g of 0, well, f of 0 is 1. If you go up to see where the f is the function with the thin line, and g is the function with the heavier line. So g of 0 is negative 1, f of 0 is 1, 1 plus negative 1 is 0. So f plus g of 0 is 0. F minus g of 0, so it's the same thing, except the sign in the middle. F of 0 is 1, g of 0 is negative 1, so we'll have 1 minus negative 1, which is the same as 1 plus 1, which is 2. F times g of 0, here f of 0 is 1, g of 0 is negative 1 again, and here we multiply. 1 times negative 1 is negative 1. F divided by g of 0, f of 0 is 1, g of 0 is negative 1, 1 divided by negative 1 is negative 1. F composed with g of 0. So so we want the output for g of 0 to take that as the input for f. So g of 0 is negative 1, and then f of negative 1, go again to the graph, go over to negative 1 and go up to see where it touches, go straight up from negative 1 and go across, and it looks like it's about 2. So f of g of 0 would be f of negative 1, which is 2. And then g of f of 0, Well, f of 0 is 1, so then we want to do g of 1, and g of 1 looks like it's about negative 1/2. So g of f of 0 is negative 1/2. And that concludes this presentation.